Today, I'm going to introduce the effects that coffee, and especially caffeine, have on our brains. Coffee is one of the most prominent drinks in our morning routine. Caffeine and humans have a long history together, since drinking tea began over 5,000 years ago in ancient China, and drinking coffee was first introduced around 1,000 years ago in Ethiopia. Caffeine might have had a major influence on today's culture. It allowed people to work more energetically, and coffee houses became a meeting point for political and philosophical discussions. But besides its major influence on society, what does caffeine do in our brain? To understand the mechanism of caffeine, we need to understand what makes us fall asleep in the first place. In order to get throughout the day, our body breaks down a molecule called adenosine triphosphate, the famous ATP. One of its breakdown products is adenosine. As our cells require energy throughout the day, adenosine levels steadily increase. Adenosine can now bind to adenosine receptors to cause the feeling of sleepiness, in addition to a variety of other hormones. Adenosine has different effects depending on which type of receptors they can bind to. The A1 receptors are found on neurons that keep the brain awake. When adenosine binds to A1 receptors, we observe an inhibitory effect and the neurons become less active. A2A receptors are found on neurons that initiate sleep. When adenosine binds to those receptors, we observe an excitatory effect and the neurons become more active, meaning that we are having a weaker wake signal and a stronger sleep signal. When we finally sleep, the brain eliminates adenosine again, and eventually there isn't enough adenosine in the brain to activate adenosine receptors, and you wake up. But what has this to do with caffeine? Well, the chemical structure of caffeine and adenosine is very similar. And caffeine can also bind to adenosine receptors. But since they are not actually the same, caffeine cannot activate those receptors and does not initiate the inhibitory and excitatory effects of adenosine. So caffeine only blocks the receptors but does not activate them. This means adenosine and caffeine are competing for the binding spots. While caffeine blocks the binding spots, the feeling of sleepiness will not be initiated, and you notice a state of alertness. Once the body breaks down caffeine, adenosine can bind to its receptors again and cause sleepiness. But when all those binding spots are blocked during a regular caffeine uptake, neurons synthesize more adenosine receptors to compensate for the blocked ones. Therefore, more caffeine would be needed to block those additional receptors to avoid the feeling of sleepiness. When a chronic caffeine user suddenly stops taking caffeine, sleep-inducing effects may intensify and withdrawal effects may occur. Coffee is a psychoactive drug, but it is generally recognized as safe by the Food and Drug Administration. It is very difficult to overdose on caffeine. 10 grams of it must be ingested within a few hours to be lethal, which is around 100 cups of coffee. Adenosine receptors are also found outside the brain, particularly in the heart and the kidneys. Just like how activating A1 receptors in wake-stimulating neurons decrease their activity, activating A1 receptors in the heart and kidneys also decrease their activity. During your sleep, the heart slows down, while less blood is filtered through the kidneys, leading to less urine production. When A1 receptors are blocked by caffeine, the heart rate increases and more urine is produced. Beyond that, medical effects of caffeine are under discussion nowadays. For example, the enhancement of pain-killing properties. Added caffeine to painkillers has a small but significant effect. A study showed that an additional amount of 5 to 10% of patients achieve a good level of pain relief when caffeine was added to pain-killing medicine. Caffeine is already added to painkillers like paracetamol or ibuprofen. Additionally, the neuroprotective effects of caffeine in neurodegenerative diseases are currently under investigation. Some researchers claim that caffeine seems to prevent Alzheimer's and Parkinson's disease. But a word of caution in the end. It is still unknown what effects caffeine has on the developing brain of children. And the uptake of caffeine during pregnancy is also discouraged. Even though caffeine has such a long history and people drink coffee daily all over the world, the side effects or possible advantages are still poorly studied. Caffeine is still a psychoactive drug that influences the natural processes of your body. It can boost focus, endurance, strength, and speed as long as you don't overuse it. And be aware of your caffeine consumption. Thank you so much for your attention.